Hello everyone, I am Devang and welcome back to another video of our project EDR. In this, we are going to cover about telemetry data collection using process monitoring with WMI. So before starting, let's have a quick recap of what we did till now. We have seen about core EDR concepts and the autonomous agent, the EDR agent, text of agent. We have seen the decoupled two-brain architecture, what it is, backend daemon, which is running in session 0, versus the front-end UI, which is running in session 1. Next, we have seen about the secure inter-process communication, the IPC, which is used to transmit data from different sessions using the name pipe. So if you have not seen that, I would recommend that go and check out that. So come back to the today's video. We are going to cover the topics which are process telemetry collection. So why we need to collect the data? What is the need? Because in ADR, before detection and doing the response, the most important thing is that we need to collect data. We need some like processes or every all the processes, some monitoring thing. Then only we can detect and respond onto it. So first of all, we need to collect the data, telemetry data. Next, about the pooling method and psutil failure regarding the performance and accuracy. How the event driven architecture is more efficient compared to psutil, and in this WMI we are using WMI specifically, and it is a com software. How we are using WMI we'll see in detail. Next, it is about the telemetry data pipeline, how the like sensing through WMI, then putting it to the queue IPC, then showing it to our front end UI. All this data pipeline we'll see, and at last about the UAC and installation detection. So we will see how we can detect the any user access control, this window, the privilege escalation, as well as any installer or any app trying to install onto our PC. So we will detect how it is detecting all this thing, and about the code base walkaround, like where in actual we have coded all this thing. So we will going to see the most important coding lines of our project. Then at last, we are going to have a key learning and key takeaways out of that. First of all, the process telemetry collection. So what is this word telemetry? It is continuous autonomous collection of OS level events. So this are means the target is either for the process creation, the network connection, and file modification. Further more things, but what is the like core goal? Like what we want. Our objective is to collect all the data, which is all the behind processes and important processes that can be further used for the privilege escalation or can crash entire PC. So we need to identify that processes. So that's why we are using that. And our approach is we are using the native Windows hook to fetch the data directly from the OS kernel. Next, it is about the pooling trap. So what is pooling trap? It is constantly pulling method, so it is constantly querying the OS. So like something iteration, while loop iteration, something like that, like did a process started now asking again and again. So it required CPU cycles, continuous CPU cycles, and also asking a OS. So this is the reason it wastes the resources, and also it creates the blind spot for the advanced malware which acts between this particular interval. If suppose our OS checks or our program checks after 1 second, so in this particular 1 second duration, what happened that some malicious or malware can attack and can execute into that particular millisecond. So this happens, and that's why the psutil, which uses what psutil dot proc iter process iter, so it iterates towards it. It uses the same model. That's why it fails here, and also it is not efficient because it gains more CPU cycles and utilizes more CPU and resources. So for that, the solution is event-driven architecture. As you can see the diagram, like postman rings the doorbell. So it is that like it reacts only when any event or process is spawned. So it we use WMI to register a callback, that we tell that Windows kernel we are putting this thread to sleep, wake it only up when any new process is created. So the biggest advantage here is OS wakes the thread only when any event occurs, any process created, and this is notified by the kernel level notification system, which we have enabled or we have called using the WMI setup. So this is how it works. So now the most important, WMI, Windows Management Instrumentation. It is the Win32 process and built in Microsoft subsystem for OS management. So it heavily relies on what? Component object model, COM model. So it is coded in C, C++, and what is it is the biggest advantage because it can interact to the kernel level developed by Microsoft only. It is subsystem processes, so it can interact to the kernel level notification system, and throughout that it can have the system calls there. But the biggest step here is our thread, our Python backend engine, and the worker threads. They are in Python. So to communicate between these two, COM and Python, we are required to use additional library that is pythoncom. And in that specific function, co-initialize there. So inside that particular thing. So in diagram, as you can see, there are further things like Python com.co initialize the com library for the current thread, and the WMI then notifies from the kernel level notification and gives the process information to the thread. And now the telemetry data pipeline, how the data has been collected. First of all, the WMI sensor, it catches the OS level event, whatever the process and events happen. Then next what happened, the memory buffer, the event queue dot put. In this, the particular payload is sent and added. So it what happens are the WMI sensor and various different worker thread we use, all they put or put this particular their JSON files into this queue. So in first out manner, this particular details are sent on to the next side, that is the using the IPC bridge and via to the session one or the UI. So this is how they worker threads are also freed because they send their data to the queue. The queue is now acting as a what I can say the virtual memory location or some kind of queue in which it pushes all the data to the IPC. IPC, as I told, we are using the name pipe, so it handles the cross session transport very efficiently. Then the session one UI, where the PyQt dashboard, it renders the telemetry and shows are the beautiful dashboard showing the event types and all the colorful highlights. So next it is about the UAC, user account control, and the installer detection. So as you can see in the right side, this screen you have like heard about it or seen at least one time in your like when you use the PC. So what is this particular screen? It is the user access control. It asks the user that do you want to allow this particular application or make the changes to your PC. It is an admin privileges kind of thing. So when you click yes, so it allows the OS to interact with this particular new software, third-party softwares, all this thing, and give you the admin privileges. So in behind or in background, what happened? Windows runs an important process while showing this pop-up. This pop-up cannot be recorded. I will show you in the demonstration, but this pop-up will not be recorded there because it is the highly secure pop-up. And in background, what happened? The consent.exe process is always running there in this pop-up. So that's why we will be identifying that this particular process is running or not. If this, so we can claim that the UAC is being going on there, and you can say that particular process or something is trying to privilege their like escalate their rights, like user is trying to get the admin privileges, something kind of that. And in the installer detection, we are using, as we are getting the process name, so we are parsing the name as if it is setup.exe, installer, or .msi, this kind of thing. So we can claim that this is particular the installer. So we can say any installer, any software is trying to install on your PC. This is how it is work. And here, as you can see, the code base. Now we have to see actually how we coded this different functionalities, the WMI, how we have created the worker thread, how we are tagging the UAC and installer using the consent.exe and the name parsing, and also about the where we made a event queue and how we are putting the data or JSON for, like payload into the queue as well as writing in the log. And finally onto the GUI where we are listening all this data, how we are displaying it to our dashboard. So let's move on to our coding console. First of all, we have our main backend engine file, that is backend daemon.py. It is overall the main file, what I can say, the backend engine, core of backend engine. In this, we have the service wrapper class. It is the main class in which we have this function def main. Here, as you can see, we have initialized various worker thread. So here only we have initialized our WMI thread also. As you can see, there are start IPC server, archive worker, and here is our start WMI monitor thread. As you can see in the argument, we have targeted towards the start WMI monitor method or function, and in the daemon we have set to true. Why? Because we want, until and unless this particular backend daemon.py exists or is running, only that moment only, for that time only, we want that this particular thread should exist. If this particular daemon file is either terminated or is killed, we want there should not exist this zombie processes, this zombie threads. So this should also be gets terminated at same moment this particular daemon.py gets terminated. So this is the logic. And in the telemetry part, backend telemetry, as you can see, we have this particular start WMI monitoring function. So this is the function. Here, as I shown you the important thing, pythoncom.co initialize. So because as I told, we want to talk or we want the interaction between the WMI as well as Python. So for that com software, pythoncom is used and co-initialize is used required in the background threads to run the WMI. Here we have made a watcher which continuously watches or is being the contact with the kernel level notification system, and as it gives it a signal alert, it the our thread gets, what I can say, initialized or wake ups, and that moment it collects the data and make the JSON, and then like this type of payload, JSON payload, and send it to event queue.put payload. As I told you, we are doing both the things. We are showing onto the front end via the queue, as well as we are logging this particular payload also. So we are writing this particular log also. And as I've told, like using this particular thing in the simple logic, as we are getting the process creation along with the various details, like PID, process ID, and process name, and various more. So using the process more and the process name, we are like extracting or parsing the important processes like consent.exe. So as I told you about UAC, user account control. So in that case, we can type that particular process as UAC detected as something is trying to like get the administrative privileges, and that pop up, the UAC pop up, as I shown you the screenshot, that particular thing has been running there. And similarly for the installation, if the installer is been running, so the process is running ultimately, and that process name, if it start or it passes for the name, if it is like setup, install, or like .msi, something kind of that, we can claim that it is the installer. Any software is trying to, any file is executing as an installer, so we can claim it at. So in the payload, we have various this things, and this is the JSON format, dictionary format, key value format, as you can see this. So this was all about the detection part, and especially the, what I can say, the WMI monitoring, process monitoring, and as I shown you the event queue. So let's see where exactly the event queue is there. So it is here in the IPC, the inter-process communication one file. We are using this particular event queue is equals to queue dot queue, this function to like create a virtual queue, and we are just inserting, pushing all these threads are been inserting this thing. As I show you more example of this particular. So as I shown you of the WMI monitor, you can see below we have the similar thing with the network one part also, and with the registry part also, as you can see this particular thing. So this is how we are utilizing efficiently the system. And in the front end, as you can see this particular live stream tab, we are listening to this particular thing. If I show you the exact code, so here how we are getting this all data, we are created this particular listening class where we are setting up all the UI thing and listening all the functions, creating the tables, and getting all the information including the severity, which is it is like critical or not, and all this thing. So this is how we are finding out the things. And if I talk at last about what how exactly we have implementing in this, yeah, it is the EDR. So let's have a quick demo how this thing is actually happening. So if I click on this particular, I've already installed it. You can see various already processes are there because it was running. So if I create a new process, suppose I create a calculator. So exact moment you are going to see this particular calculator is created. This 1838. If I show you time 1838, the exact moment it is created. Take example, or if I install this particular file, quick share setup.exe. So first of all, this is a software or installation part. So USD screen should be visible. Yes or no. Do you want to install, make changes or not? Yes or no. That pop-up screen would not be visible to you. I can see it right now, but it will be not visible because window isolates it. But you can see the installation is started, and this particular thing is being detected here, as you can see. The installer detected this quick share setup.exe, and the USC detected using the consent.exe. I told you this particular process is what most important, because if it is running, it is 100% necessary that window has suspended all other processes for that particular millisecond and is running and showing the pop-up screen for the administrative right. Do you want to do this action or not? And similarly, you can see various things like behavior, bypassing the hidden windows, executing PowerShell. So this particular installer is trying to download something from the like internet or all its dependencies, more packages. So it is detecting that also that particular file in your PC is trying to install something from outside internal internet and outside network, external network. So that is it is detecting all this thing. So this was all about the demo. So after going throughout our code base and also having a quick demo of how the things actually works in our dashboard, let's come to the last point, that is our key learning from this video. So the first of all is never pull the OS. It means the event-driven architecture is mandatory for performance and accuracy in security engineering. No doubt, we should always focus on performance and efficiency. Next is about the thread safety is crucial, or it is critical basically. Like we have used WMI, it is a kind of Windows API, and it strictly adheres to what the COM softwares, and to communicate between this particular, to interact with this system calls, what we require is the different Python module, that is the pythoncom and the co-initialize method. So this was the key learning there. And rather than like for the UAC part, rather than just detecting the process it is created, we are detecting that also that that particular process created is harmful, or it is like something suspicious process. Because if any user, if you are genuine, like I am genuine, of my like I am the owner of my PC, I am doing this, and if the admin do so, it is also genuine. But if any malware, any virus tries to do this particular thing, like try to access any software, try to install any software, so this is how it is telling that this particular process is harmful to our system. So this is detecting all this thing. And at last we have shown about the event queue, like event queue, how efficiently we are managing that. The different threads are there. I have shown you only about the WMI monitor. There are many other monitors like network monitor, download detection, software part. All this detection, all these worker threads are simultaneously, asynchronously running there, and they are throwing out, they are transmitting their data, JSON data, to our queue. So our queue is getting that, storing it, and one by one in a first in first round manner showing to our dashboard. So such that our worker threads are resting or sleeping at that moment and can do other work, not just like traveling or showing their data only to the things. So this was all about in this video. Thank you for watching.